Lesson 2, still quadratic number patterns, the homework. First question said, first of all, find the next term. Now the moment that we see the quadratic number pattern, well, we don't see it, we've got to realize that it is a quadratic number pattern by doing first differences and second differences. For this very moment, you know about linear and you know about quadratic. Now linear has got a first difference that's common or constant, and quadratic has got a second difference that is constant. So we check out the differences first. Then we're going to find the next term. What are the differences? Help me. 12, 18, 24. So that the second differences were 6. So if we do carry on with that pattern, this should be 30, and then this should be 91. Now please don't just give them that answer in a question paper. Tell them the next term is 91. Which will be 2 marks, I estimate. Second part of the question said, find the general term. Which means we've got our formulas. 2a, 3a plus b, a plus b plus c. And those are our 3 steps. Step number 1, 2, 3. For finding 2a equal to 6, meaning that a is 3. 3a plus b equal to 12, 3 times 3 plus b equal to 12, and b is equal to 3. Number 3, a plus b plus c is equal to 7, where we know that a was 3, b is 3, and c will then be equal to 1. So that our general term is 3n squared plus 3n plus 1. Do you need to first write an squared plus bn plus c? No. But you can if you want to. Right, and then the last bit of the question was, what is the 100th term in this pattern? So what must I do? Substitute n with 100. And it gives me 30301. Thank you. Done. Question number 2b said, do I know what that pattern is by just looking at it? No. Can you say that that is linear or that is quadratic? No. You can't. But they do say the following pattern is a quadratic pattern, find x. That was the question. Find x. So if I want to go and find x, and I know that it's quadratic, what is the fact that I'm testing? What do you know about quadratic? Second term is constant. So that's why we go for first differences, which are 12, x minus 13, 28 minus x. Crucial, second minus the first, third minus the second, fourth minus the third. You can't swap them around. And then to get to the second differences, that'll be x minus 13 minus 12, 28 minus x plus 13. And then the next mark is going to be for you showing me that you know that that is equal to each other. Whether you show it there a little bit later. I need to see the first differences and I need to see your second differences. Most of the time, it's a mark for first differences, a mark for second differences, then a mark for putting them equal. And if you put them equal, what type of an equation is that? Linear. So I'm solving for x, bringing them across. So we've got minus 2x becoming a plus 2x, giving me 3x. Equal to? So again? 66. And therefore x is equal to? 22. Could x be a fraction? But I don't think to make the pattern quadratic that would have worked. But it could have been a negative number, and it could have been a fraction if it made the pattern work. Could n, the position number, be a fraction or a negative? question was just find for x. Right. Then they also did ask that you must find the nth term. How do we find the nth term? It's exactly the same sum again. So for finding the term, then it'll have to be x values was 22, 28. So we're going through our motions. 12, 9, right? 9 and 6. And this is negative 3. Very careful, guys. Don't make a mistake and say that that is 3. And nothing wants to work because you said 3 instead of negative 3. First, 2a equal to. Second step, 3a plus b equal to. Third step, a plus b plus c. Now guys, after today, we're not going to specifically look at this again. But you're going to constantly be asked this again and again. In this term, in the June exam, in the prelims and the final, you're going to have to know this. So you all know this now. Yesterday, you might have forgotten about it when we looked at it the first time. Why did you forget? Because you didn't do it the day before. You need to constantly be practicing it so that it doesn't go out of your head. So when we've got those values, we can now, I'm going to do it here quickly. So we've got 2a equal to negative 3, giving me a is negative 3 over 2, which is a fraction, and so be it. Second step is 3a plus b equal to 12, where the a value is negative 3 over 2. What is the b value, please? 15 over? Over 2. Thank you. Why was I confused? Because how could it be? Okay, well, with these values I can't see it working. Everybody happy on that? A plus b plus c is equal to 1, where a was negative 3 over 2, 15 over 2. What is c's value, please? Negative 5. So that my general term is negative 3 over 2n squared plus 15 over 2n negative 5. And that is my general term. Typically, this finding the general term is about a 4-mark question, always. Question 3 says, a little bit more difficult, that there is a quadratic pattern that has a second term that is equal to 0, and a third term equal to negative 6, and a fifth term equal to negative 24. So to get the information onto paper, the second term is 0, so I'm shorting term 1. So let's make it x. The second term is 0. The third term is negative 6. And then the fifth term is negative 24. So I'm shorting another one here. So x again. Definitely y, because they're not the same. If you call them both x, they are the same, and they're not. Unless they said so. So that would mean I've got a typical question again, knowing that this is quadratic, because I said a quadratic pattern has a second and third and fifth term like that. And they want me to find the first term of the pattern and then to find me the second difference as well. So all I know is it's quadratic. The only fact I can use is quadratic. So the only fact I use is that there's a second difference. So we have to go look at the first and second differences. First differences? Minus x. How come? 0 minus x. Not just x. 0 minus x. Minus 6 minus 0. Why? Plus 6. And negative 24 minus y. Rather put the stuff there, the zeros. Then for the second difference, because the first differences are a linear pattern in which there is no constant first difference. It makes a linear pattern, and that linear pattern again makes up a constant difference. The constant difference here would be equal to each other. Now let's get them. So it's negative 6 plus x, right?
Yes.
For this one, it's y plus 6 plus 6. And the 0 there. This one is minus 24, minus y, minus y, minus 6. Don't make mistakes there. It's always the same routine. But the fact of the matter is that they are all equal to each other. But please don't write it like this and say equal, because what you're going to do then? Now we need to use these facts that this negative 6 plus x is equal to y plus 12. I've already added that. And also, these two are equal. So y plus 12 is equal to negative 2, negative 30. I'm adding them so long. Are you with me here?
Yes, ma'am.
Negative 2y, negative 30 is equal to y plus 12. Couldn't I have also put this equal to that? Because they're all equal to each other. So I could have put first and second together, second and third together, or first and the last one I could have put together. But now tell me, how many variables are here? And here? So which is the place that I would like to start? If both of them had two variables, what would you do? Simultaneous equations. But this is a bonus. They're giving me a bonus present. So let's do the y first. So this is going to be 3y equal to negative 42. Am I right?
Yes.
Which gives me negative 14. Now that I know what y is, I can put it back in here. But please, guys, tell the person marking your question paper you know what you're doing. So I'm going to call this number 1 and this number 2. And I'm not going to cram everything in here. I'll carry on and I'll say I'm going to put 2 into 1 so that everything looks nicely set out. And if I do that, put 2 into 1, then this one comes in here. I've got minus 6 plus x equal to y, that is negative 14 plus 12. So I'm substituting the y with negative 14 so that my x value works out to how much? 4. Yeah. So if x is equal to 4, what was the question? Find the first term. Did I answer then the question? It's there, but it's not there. Because I called the first one x and I did find x. But please answer the question and say, okay, there's term 1. Or the first term is. Answer the question. Second question is, find the second difference. How do I find the second difference? Where's the second difference? Any one of them. Choose one. Don't do all of them, because it should be the same. So if I chose that as my second difference, I can just substitute x with 4, and I'll know what the difference is. Are you with me? Short way. So for the second difference, it'll be negative 6 plus 4, which gives me, and I'm done with my sum. How many of you would have wanted to go right back to the top again and redid the thing? Is it right? You could have done it. You could have gone and said, well, x is 4, then 0, then minus 6. Y we know is negative 14, and then the negative 24. So this child is doing something completely different to that one. Sum is done. 2 marks, maybe just 1. Whatever you're doing here is also going to just be 1 or 2 marks. So now I'm doing differences again, which are minus 4, minus 6. Again, I can see the pattern going here, that this is constantly. Answer the question. The second difference. So whether you did this or just got it from there, you're on the same track. Different way of thinking. Because you could just go there, if you knew the y, if you filled in the minus 14 there, minus 14 plus that gives you negative 2. If you put it in there, minus 14 becoming a plus, etc., etc., it's going to be minus 2. Whichever way you do it, you've got your second difference. Right, now it's getting to be routine work to find the general term. So even if it's large numbers, it doesn't matter. You get the second difference, you get the first difference. You've got your formulas 2a, 3a plus b, a plus b plus c. Substitute the a in, find the b, substitute a and b in, and you find your c. So you've got your general term. 4 marks. Second part of the question says, which term has a value of 0? which term or terms they also said. So if I go and do that, I've got to put the formula equal to 0. I don't think anybody would have put n equal to 0. Makes no sense. Which term is number 0? The athlete that didn't pitch up is number 0. What? Are you with me? Position 1, 2, 3, it can't be a 0. We put it equal to 0 because it's which term. Now we've got our fantastic new calculator. So n is equal to 20 or 22 if you use your new calculator, which works how? You say mode, you say equation, which is number 5, I think, and then you say the third one, which is a quadratic term. Then it asks you for A, B, and C. A is 1, and we enter. B is -4, and we enter. C is 440, and we enter. And when we enter that again, we find that n is equal to 20, not n, it says x. X is equal to 20, and x is equal to 22 when you enter it again. And you can even go on with it. The next one it gives you is not only that x1 is 20, x2 for your second prompt is 22. It also tells you, the next one, that the minimum value is equal to 21, and that your y value for the minimum is equal to this. Your calculator is giving you your turning point. Giving it to you. Get the calculator. So we know that the x is the only thing that you mustn't do now is write x. We're solving for n. And now going back and crooking it right to show the factors means that this should have been n minus 20 and n minus 20. So, and if you were looking for it with your own brain without the calculator, you should have thought which are the factors of 440. 1 times 440, 2 times 220, etc., 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 until you found that 22 and 20 works. Get the calculator. Alright, so that means that at that space they're going to have a value of 0. And then the last part of the question, asks a funky question, and it'll be 2 marks. They want to know which term will have the least value, which term will have the minimum value. Now think about this. If you got it, you'll catch it. If it's a value of 0 at term 20 and a value of 0 at term 22, where's less than that? Because this was a quadratic parabola, right? Quadratic parabola. So thinking about it, I'm actually on my numbers, on my set of axes, and at 20, where n is 20 and where n is 22, it's going to have a y value of 0. A y value of 0. So this is actually t and then this is n, right? But because it's a positive parabola, it should look something like this, right? But now, this doesn't make any sense because this will be n is 1, 2, 3, 4. N can't be. So that's why I'm stopping there. Just getting a little bit technical now. But where will the least value then be? At 21. How come? Because the parabola is symmetrical around the turning point. And if the two x intersects where y value is 0, y value is 0, is 20 and 21, then that should be for n equal to 21. Or term 21 is going to be the minimum value. What the minimum value is? How would you find that? How? Knowing that n is 21 in the general term, you can find it. Guys, you could also find the turning point using, if ever you had to find minimums and maximums, you were also taught to use the completing the square. Because if you complete the square, you are going to get the you're going to get the turning point. And I know it because I've done it before that you came here, that it's going to be -1. If you take that and you go do your completing the square, it's going to be this value, which means that the turning point is at 21 and -1, and that's also why I knew it here. Your calculator actually gave it to you. That the minimum value would be where n is equal to 21. But without all of that, think about it. Positive parabola, it's 0 there, so which one will be the least? Term 20, term 21, term 22. In actual fact, we shouldn't be sketching it like this. We should be sketching it like term 19, term 18, and nothing in between. Because there isn't a 19 and a half and a 1 quarter. And we're thinking of the facts. Do you catch where I say that it will be for a minimum value would be at term 20?